is on archive. And also, yeah, I'm happy to take any questions via email or here or any other form. So thank you for listening, and I'm going to open up the floor.
Thank you very much, Marie. This was excellent, and as we promised, excellent slides too. And thanks for your insight into whether including the diversity statement at the end of your paper took you. So we have ample of time for questions if you have one. I think we're a small group, so it's fine to just unmute yourself and ask, or if you want to, you can raise your hand and I can call on you, or you can just type it in the chat if you want to. In the meantime, I'll get started with one. Oh, we have one by Tim. Let's let Tim go first.
Sure, thanks, Alice. And I'll also note there's one in the chat also. So when I'm done. So thanks so much for this awesome talk and awesome work. I'll start with the comment on your last part and a little plug. So that was really great. And on your last question of the kind of where we draw the line between science and political advocacy, I happen to be a member of an organization that thinks a lot about that in particular. It's called Science for the People. It's a group of radical scientists who generally don't think that there's such a distinction between science and political advocacy, and that we actually should be actively trying to consider political advocacy, quote unquote, or the social repercussions of science in all of the science we do. So a little plug for Science for the People. We also publish a magazine, so you can check that out. I'll put the link in the chat after. And then I had a question. So I'm curious in terms of the actual choice of endorsements. It seems like you've kind of chosen your utility function and the way that the endorsements are chosen slightly for convenience, which totally makes sense. There's a lot of moving parts here. But I think a natural thing that I thought of is like something like complex contagion or like voting in terms of endorsements. And I just wonder, and the example that you used of Phil's of Joe Biden and Bernie Sanders like makes me think of that explicitly. So do you see a way, or have you tried to incorporate complex contagion, voting, that kind of things for choosing endorsements for that piece of the model?
Yeah, that's super interesting. I haven't thought in depth about this. When you say complex contagion, my understanding would be that, it's kind of a process that would require multiple endorsements in order for something to happen, or is that correct?
Yeah, that's exactly right. So 3 of my friends use Macs out of 5 friends, and so I choose to buy a MacBook rather than a Windows computer in a simple example.
Yeah, right. That's definitely true. So in terms of like the number of endorsements that are needed, I'm not sure that our current model necessarily accounts for that, but I think it does. As of now, it makes a difference. If you're like, I don't know, some big Mac person who has power in that world, perhaps you will have more influence on that dynamic than others. So, but yeah, no, that's a really good question. And I didn't think about the connection between voting and this model. So thanks.
Thank you.
Yeah. I think someone raised a hand, and I also see a question in the chat. Let's see, Aiden asks, could one use a generative model for the dynamics of hierarchies using time-varying networks in which new links are formed based on the preferences of nodes in the current network, where old links are not forgotten over time? And if so, how would that model look like in real? Yeah, that's a great question. So my understanding is that actually a lot of the existing models don't think about the decaying of nodes, not nodes, preferences over time. So, when you think of some abstract growth model of a network, right? The idea is that it basically, the new things that come, whether it be endorsements or links or nodes, they add to the existing structure. As for how it would look, I would say, so I think hierarchy can emerge in that kind of a system as well. I'm not entirely sure, how exactly it would compare to this model, but interesting thing about incorporating memory the way we did is that, right, for example, in the math PhD system, we don't, this is the people, there is a turnover in terms of the people who are operating the system. So we wanted to see, how much of that is actually maintained over time. Does the time span correlate with some sort of a turnover, or is it the case that once the system is established, like, it kind of continues that way? Is the hierarchy that entrenched? I hope that answers your question. Is there a maximum minimum number for delta? Delta is the endorsement matrix. Let me see if I can pull it up. Yeah, what do you mean by maximum minimum number? If you don't mind elaborating. I don't know if I can show you an example. Hold on. Let me see. So this is what a lambda next, the max number that it can take as a parameter. Maybe this example will help. So this is an example from the math case study. And one example of a delta matrix is given here in panel D. So this just basically keeps track of who endorsed whom at each time step. So, maybe this gray is one endorsement made by this row individual towards the column individual. I'm really sorry if I'm not understanding your question. In terms of the number of endorsements, M, that can vary from, I'm not sure what so we've tried anywhere from 1 to a couple of 100, if I'm not mistaken, in one of the data sets.
So I think we have another question from Nick and then from Carrie, who have raised their hands just now.
Thanks for a great talk. My question for you was, so I might be misunderstanding this. So nodes themselves don't have any intrinsic qualities. Is that correct? In the sense, like, they don't have ability or this or that. So I guess a question that I would ask is, super fascinating, by the way. I would be curious to see how that interplays with the theoretical model that you have. So, like, is there like a certain level of strength of a node that can help you overcome the, say, something like that?
That's an excellent question.
Thought of that?
I haven't thought about it. But I agree that would be really interesting to see. And right, in reality, in a real system, there is certainly the effect of intrinsic variation among the nodes. That's also at play. And there's some balance there. So yeah, I don't know what would happen there, but thanks. That's a great suggestion.
Thanks for a good talk.
And then we have Carrie, who has raised her hand.
Yeah, thanks. Great talk. It's really nice to finally get a chance to join this seminar since I've been teaching or other meetings at this time. But really refreshing what you've done, but also I think some of the issues you raise later, in particular with citation networks. And so you sort of had an invitation to discuss, and
Yes.
I was just curious. So one of the practices that I have seen from an individual, it doesn't seem to be common yet, but I put the link in the window, was from somebody, not that did citations, but rather that examined their own collaborative practice with respect to gender as well as underrepresented racial axes. And so I wondered, it looks like people are starting to examine their own work in a variety of levels. And I was just sort of wanting to talk a little bit more about that, or if you thought about race and ethnicity as well, in addition to gender.
Yeah, definitely. We focused, because the citation diversity statements was initiated as something focused on gender. That's sort of the approach we took. And the other thing is that it's much harder and often not possible to determine race in terms of citation analysis that is just from names. But yeah, I certainly agree that we do need to think about the intersection of those. So thanks for raising that point. Yeah, and I will definitely check out is it a Twitter thread?
Yeah. Well, and I think about it too, just because in terms of teaching, I'm trying to draw from literature that's representative also of various race and ethnicity, as well as a picture, a scientist, thinking more broadly about that. And yeah, so not just on these like sort of large scale mining things, though. I know qside has done some things where they sort of approximate with Amazon Turk, make some educated guesses, which have to have a lot of asterisks. But
very cool.
There's a question from Joel.
Yeah.
Hey, Marty, I really enjoyed the talk.
Thank you.
I guess I was a little curious. So you have a model where people have a one-dimensional perception of sort of status, and the network recreates a one-dimensional perception. I think sort of like the example of politics is pretty interesting, because I think in politics, most people perceive multiple dimensions where there's both like a left-right axis and then there's like a status thing, and endorsements are pretty dependent on like, where you are in sort of like that two-dimensional space. And so I guess I was a little curious if you've thought about sort of higher dimensional, having people with higher dimensional spaces and then mapping that to a ranking.
I'd love to be able to do that. I'm not sure that I know how to yet. In a related project that I'm working on, I'm thinking about multidimensional opinions in terms of political polarization. And I think it's a sort of similar. First of all, the definition of hierarchy becomes definitely more complex, right? When you have two components. So that's a question perhaps of definition, but I do think there's probably a way to extend our model in such a way that, maybe in one time step, individuals are making decisions along one axis and then along another in a different sort of in a sequential way. Perhaps that could solve that problem, or maybe in some weighted, the two axes are weighted together or something like that. But yeah, I mean, I don't know yet how exactly to model that.
Yeah, actually, I mean, I think on the second part of your model, you could just take the math, and if you just replace some if you just assumed vectors had magnitudes and then also a difference on like the distance between them, right? But yeah,
I see. Yeah. That's a great point. Yep. Well, maybe we need to change our next project then and think through this question as well.
Sort of, I think an overarching interesting discussion question would be, so you have a situation where people have one-dimensional preferences and it gets mapped into data, which you infer as having one-dimensional structure, right? And that's sort of interesting that the dimension of the structure neither significantly increased nor significantly like decreased. And whether that's true of sort of like at higher order like perceptions, I think would be pretty interesting.
Yeah, I would have to think more about this. This is
sorry.
No. This is super fascinating. I just haven't wrapped my mind around it. But thank you. That's a really. I will actually write it down and think about it. Yeah, thanks.
So there's another question from Giovanni. Or maybe not. I don't know.
Giovanni, yeah, you said it right. So my question, I guess, kind of related to like Joel. So it was like with different aspects of, because currently it's like kind of there's just one kind of endorsement function kind of space, and I was thinking like, oh, like, you know, what about if we have two different kind of spaces that like aren't directly related, but it's the same like kind of nodes or people in each, and it's like could influence from the other, affect the other space, even though like maybe directly they don't actually have any connection. It just happens to be the same people, but like, like you've heard of this name before, and so they get automatically some sort of like recognition in the other space, even though it doesn't have anything to do with whatever the previous thing or the other thing was.
Oh, I see. So if I'm understanding correctly, maybe we can picture it as some sort of a multi-layer network or multiplex network. It's captured.
Yeah, I guess that could be one way to do it.
Yeah, I think that would definitely be interesting. And if you've managed to do it, please let us know. You know, we were just trying to get the one dimension, you know, basically one layer, right, to get to work. But
yeah,
I think, I'd imagine that perhaps when we're thinking, especially about individuals moving from like one academic field to another or something like that, you know, we were looking at math PhDs, but perhaps there's some correlation, right, of the reputations there with some related field or connected field or some interdisciplinary collaboration or something like that. So I could see it being applied to something like that.
Yeah, this is still a really great and interesting talk and work, though, even like just starting at this one-dimensional kind of layer.
Thank you.
So I'm going to potentially add just one small question at the end. I absolutely love this because it combines networks and dynamical systems, which is all that I'm about. In terms of kind of the trajectory of your network system as it evolves through this endorsing process, is what are the kind of things that it can converge to? So there's the case where you just don't get any hierarchy at all. So you have all of the nodes kind of have similar rank for, I assume, eternity. And then if you do get a hierarchy, do you actually have like a stable winners effect that gives you the scenario where one node has all of the influence and all of the other have basically none? Or is there like more diversity in the scenarios that you can get in the long term?
Good question. Let me see if I can pull up so it depends partly on whether we're thinking about the expected dynamics or the original stochastic dynamics. So in this example that I showed, let's see. So in these examples that I showed, these are the stochastic simulations. So there are cases, as you said, you know, there's basically everyone has more or less the same rank all the time. But then there are also cases where you get multiple individuals that are not in the bottom bunch.
Did you initialize them to be that way? Because it kind of looks like you started with a different initial condition for that simulation.
Oh yeah, that's a good question. I believe we started with the same initial conditions. Actually, it's because the beta one is so big that the sizes change. Although it's possible that we had to stabilize the first couple of steps, and I need to go back to the code and check for that. Yeah, good question. But in the expected dynamics, in this case, basically all these branches correspond to one individual taking over at the top. So, but that does correspond to a very large value of beta 1. So the interesting stuff is happening at the sort of intermediate range, you know, around here, or around here.
If I can expand on that a little bit, I think Spring Rank is a really interesting case here, because in Spring Rank, you do have this multi-stability for intermediate values of beta, so that there are different degrees of hierarchy corresponding to how many people are at the top. And if you imagine a little bit of noise, the system can stochastically switch between those different stable regimes.
I see. That's interesting. But you don't get those. You get those only for Spring Rank and not for page rank and root degree.
Yeah,
Right?
for reasons that at least I personally don't understand, Spring Rank seems to be considered.
Right. And it's interesting because Spring Rank is, I believe, of the three, the only linear function, correct? I think PageRank is nonlinear, and also root degree is as well. So, and I think that explains this sort of backward bifurcation, so to speak, or the stable equilibrium emerging before the transition happens. But in the case of Spring Rank, nothing happens before this transition, but then there's lots of stuff happening here. So, yeah.
That is super interesting, and actually kind of makes more questions pop up in my head than before. So it's really cool that you came up with this model that not only answers questions but kind of throws out lots of new ones. And yeah, I guess we're at time. Thanks for everyone who was here and asked a lot of questions. Thanks for Marie for this excellent talk and this excellent Q&A and the discussion. And yes, hope to see you all again next week. Thanks.
Thank you, Alice.